Calculus Lesson 32. Alright, what we have here is what's called the antiderivative, okay, or the indefinite integral. Okay, integral or antiderivative. And this actually has a lot of usefulness we'll find in later, a lot of practical things that we can apply it to. Now, a little bit of review. Okay, if we took the derivative of x squared, remember we put the 2, multiplied it out in front, which gives me 2, and then subtract 1, it would be 2x. Now what occurs is that we can also get other derivatives of 2x. If I took the derivative of x squared plus 42, well, we know the derivative of x squared is 2x, and we know the derivative of any number is 0, so this would also be 2x. And we see, we actually could get an infinite or indefinite amount of answers. You take the derivative of x squared minus 165, you also get 2x. Okay, so now what we have is called the antiderivative. We're working backwards. So if I wanted to take what's called the integral or antiderivative of 2x, okay, we would say the antiderivative, or if we start with 2x, going backwards, the antiderivative would be x squared. Okay, now here's the problem, and this is a symbol. If we're going backwards, okay, if I were to take the integral or the antiderivative, I want to go backwards, we go backwards, we get x squared, but here is the problem. All right, we also note notation saying that we're going backwards from taking a derivative. We have dx. The problem is, when we go backwards, we have x squared, but x squared is not the only answer. Okay, we could also have plus any number, and it still would give me a derivative of 2x. So this is where, for these indefinite integrals, where there's an infinite amount of answers, we put plus c, which just stands for any constant.